Welcome back to Ergstown, 4th grade engineers. Today we are on lesson 2.3, activity 4, energy in the system. Let's review our unit question. Again, what we're focusing on for this entire unit is to figure out how the electrical system works. Today, we're going to continue exploring why all the devices in Ergstown would stop working. To do this, we're going to use a model to represent the electrical system. Do you remember what a model is? We talked about it previously. In case you don't, a model can help scientists and engineers understand something by making it easier to see. And a model is used to represent something else. So we have water in cups. We're not really showing water in cups. We're using those to represent parts of our electrical system. So our pitcher of water represents the energy that goes into the electrical system. And the cups represent the devices converting energy from the system. So our electricity that's coming in is the pitcher of water, and our iPad and our lamps and our lights are the cups. Now what I want you to do is answer these two questions. They are provided for you in the graphic organizer and Seesaw. Question number 1. Why is this not a perfect model of the electrical system? And question number 2. How is it different from the electrical system? So I want you to stop the video. I want you to answer these two questions and then come back. All right, so you've taken time to try to answer these two questions. Go back to them. And let's see if we got the same thing. Here is why I believe it isn't a perfect model and why it's so different. First of all, there is more than one source of energy in a real electrical system. In our model, we only have one source of energy, the pitcher with the water. Also, there are more than 3 devices getting electrical energy. Think back to Ergstown. Think even to your house. Do you have only 3 things that use electricity in your house? Probably not. And think a whole town like Ergstown definitely has more than 3 devices. Also, if you think of that simple electrical devices or systems that we make with the solar panels and the motors, they're all usually connected by wires. Do you see any wires in our model here? You don't, so that makes it different as well. And you can't turn on or off this model, can you? But I can turn on and off a light switch in my electrical system. So our model isn't perfect, but we can still learn things from it. It can still help us understand why the devices stop working. Here's our goal. Our goal is to power all 3 devices by giving them enough energy. In our model, the devices need to be filled all the way up with water in order to work. So cup 1 needs to be filled all the way up with water. Cup 2 has to be filled all the way up with water. Cup 3 needs to be filled all the way up with water in order to work. Remember that all devices, all electrical devices, need a certain amount of energy to function. Some take more than others, but in our model, every single one needs to be filled to the top in order for them to work properly. So what you're going to do is finish up this video and you're going to watch the demonstration of this being done in real life. And then remember, tell me what you learned after watching that video.